Jaichandran, sir.
Yes, madam.
Shall we start the session after 5 minutes, sir?
Okay.
Because participants yet to join, sir.
Okay.
Thank you, sir. Sir, shall we start the session, sir?
Yes, madam.
Okay, sir. Good afternoon, all. I welcome you all the participants for the afternoon session of AICT sponsored faculty development program on sensor technology. It's my immense pleasure to invite Dr.R.Jaichandran, sir, Professor, Aarupadai Veedu Institute of Technology, Chennai. Welcome you, sir.
Yes, madam. Thank you.
Dr.R.Jaichandran is currently working as a Deputy Director Research, Vinayaka Mission Research Foundation, and Professor in Computer Science Engineering, Aarupadai Veedu Institute of Technology. He obtained his B.Tech degree in Information Technology from L.Tech under Madras University in the year of 2004 and ME in Computer Science Engineering from Nurul Islam College of Engineering, Anna University in the year of 2006. He obtained PhD in Computer Science and Engineering from Vinayaka Mission Research Foundation in the year of 2017. He has developed many innovative projects in the area of Internet of Things and machine learning. Some of his projects got selected for AICTE Chhatra Vishwakarma Awards in 2019 and 2018. He is selected as a regional winner and exhibited the project at nation level convention held at AICTE headquarters, New Delhi on 20 and 21st Jan 2019. He has 16 years of experience in academic, industry, research and development activities. He received grants for executing innovative projects from reputed organizations like Tamilnadu State Council for Science and Technology and Computer Society of India. Received 2 innovation patents, and 2 patents are in published state and 2 patents are in field state. Published 69 research papers in referred journals and conferences inducted in Web of Science, Scopus, IEEE, UGC CAR, Google Scholar, etc. His area of interest includes artificial intelligence, data science, cybersecurity, wireless sensor network, and Internet of Things, but not limited to. He has attended 84 faculty development programs, workshops, seminars, and delivered 34 special lectures in various reputed organizations. He is a peer-reviewed manuscript for many reputed international journals and conferences. He has awarded A+ grade 2 times by Infosys in Campus Connect Train the Trainer program. He received Best Researcher Award TSFA 2017 and received from Honorable Chief Minister of Pondicherry, V. Narayana Swamy, sir. He won Best Project Award in VISA 2013 International Project Competition and Exhibition. He is a member in Computer Society of India, Indian Society of Technical Education, Association of Computer Electronics and Electrical Engineers, and member in International Association of Engineers. Now I invite Dr.R.Jaichandran sir to share his research ideas and knowledge in the field of role of sensors, IoT, and machine learning in healthcare system. Welcome you, sir.
Thank you, madam. Thank you
you.
for introducing me to the audience.
Thank you, sir.
Can I able to share my screen, madam? Because the screen
Yes,
sharing
sir.
option is not enabled.
1 minute, sir. Okay, sir.
Thank you, madam. Thank you for sharing the screen.
Thank you, sir. It's visible, sir.
It is visible, madam?
Yes, sir.
Good afternoon to all. Thank the P.S.R. College Management for inviting me for this ATAL FDP program on sensor technology. Hope you will be enjoying my session. I'm Dr.R.Jaichandran from Aarupadai Veedu Institute of Technology, Vinayaga Missions Research Foundation. I'm going to take the session. The role of sensors, Internet of Things, and machine learning in healthcare. So this is a state-of-art topic today, what everyone is expecting us in this pandemic situation. The healthcare industry is booming, maybe in the positive sense or negative sense. Today, you know that the situation that the hospitals are full and the hospital management are struggling in providing service to the patients, right? So now it was a serious concern. We need to improve the technologies in the healthcare sector. Certainly, this is going to happen in the coming years and creates a lot of job pockets for the young engineers who is going to coming out in the nearby future, right? Am I audible and my voice is clear? Hello? Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Yes.
It's clear, sir.
Yeah. So if you see, what are the challenges in the healthcare industry today? If you know the challenges only, then I can give you a solution to the challenges, right? The first challenge what the healthcare industry is facing today is the safety of patients, the staffs, the frontline staffs, and the healthcare equipments. How to provide safety to this, your patient or your staff working in the hospital, or the healthcare equipments whichever used in the hospitals. Because in today, you know that in uh, the multi-store hospitals, very huge number of patients are handled, and there are a lot of staffs, and healthcare equipments is involved is very huge. And how I am going to manage this as an big hospital management, right? This is the first concern which every hospital today is having, and how I am going to implement the solutions to this. Second, how to monitor the movement of the healthcare equipments and its usage. I have a lot of healthcare equipments to facilitate my patient, whether it is used effectively or otherwise, how I will monitor where it is gone, to whom it was used, and what is its usage percentage, right? And third, the challenge is the remote monitoring of patient. Today, you know that we are not able to go to the hospital frequently, right? And sometimes people are busy. So, but the data of the patient has to be monitored frequently for giving further treatment. So, the remote monitoring is one of the important aspects which nowadays came into the hospital management. So, the patient need not to come to hospital, the doctor need not to come to hospital, but the process will happen, right? And the remote controlling of healthcare equipments, how to control my equipments without going physically going to the place and operating it. Right? Now, another important thing of today is, you know, that most of the hospitals are computerized. I collect patient records, I store in my computer. So every year the data is increasing, and I have a large volume of data of patients to know the data are the assets. But how I am going to use this data? Is really this going to helpful in improving my treatment? The question, yes. Today, the patient data are your assets. It can be used to train the machine learning models, and it can be used as a automatic directing machine. You know that if your hospital has experienced doctor, the people will come to your hospital because they say that if I go to that hospital, my problem is solved very easily, right? Because you have an experienced doctor. What is an experienced doctor? Experienced doctor since last 20 years or 10 years, he is in the field. He has treated a lot of patients. You know what to do with the patient, how to recognize it, how to diagnose the disease effectively, what is the treatment can be prescribed to the patient. These are all the things he knows because of his experience. So all these things is entered in some part of the computer and stored as a record. If I train a computer with this lot of data, then my computer became an expert system. It almost worked like an effective doctor giving suggestion because it has the knowledge of last 20 years patient record. So this is the thing which is going to change the healthcare industry. So for changing the healthcare industry, the Internet of Things, sensors and machine learning plays an important role. Whatever I so far discussed, I play on video, you see that it is an imaginary or a futuristic view of how the healthcare industry is going to be changed if Internet of Things and machine learning is applied in the hospitals. I play this video, whatever I told now, you can see in the visual how if it has happened in the hospital, how it looks like. Is this clear? Is this clear? Audible?
Yes, sir.
Yeah, thank you. So whatever I discussed, that is the safety of patients, the safety of staffs, the safety of the equipments, the usage of the healthcare equipments, the records, how the records are used, how the movement the patients are monitored. All these things, if it is implemented in an hospital, it looks like this. And hope now you understood how this technology is going to revolutionize the healthcare industry, right? This is even already implemented in some of the hospitals, but not in all hospitals. But these are the fact that is going to happen in the future in our hospitals, right? So if I want to do this type of implementations in hospital, I need a large human source with a knowledge of Internet of Things, machine learning, right? So there is the need for the IoT engineers and machine learning engineers who can implement these projects in hospitals, right? So that's why we are going to IoT and machine learning, right? So now I come into the topic. For implementing such ideas, what are the things or what are the technical knowledge I have to develop, right? That is the core theme of my presentation. So you see the IoT, the interconnected objects that transfers data without the human intervention. That is the definition given to the IoT. Now, to do this, what are the technologies that has to be integrated, right? I need a sensor, I need a microprocessor or a microcontroller, I need a wireless module, I need, I should have some programming knowledge, preferably Python programming, and the software packages for writing my program. So these are the basic components which will enable the IoT. So enabling the IoT sense, I can able to monitor something. I can able to transfer that monitored data to the required station, based on which some action will be performed, whether it is an healthcare related object or any other things, the same procedure, right? Now we will see the sensors. What are the sensors which can be used in such applications? So here in the screen you can find these are the different type of sensors. Sensors basically monitor the environment, right? Or triggers an action when something happens. For example, in the screen, you see that baby theft detection system, right? Some in the hospitals nowadays, you see government hospital, the baby are theft. How to prevent it, right? So in that video, there was an baby safety band which was weared in the hand of the baby, right? Both the father and mother was in the sleeping state. They are tired, and someone is coming and picking up the baby, right? And there he is trying to move out of the room. Now the sensors alerts that the baby was taken by some unknown person and he is moving out, right? This is the how the safety is provided to the patient. In this situation, this flux sensor, you can see in the screen, this flux sensor is used. What is this flux sensor? Flux sensor is a type of sensor which will trigger an action when someone is trying to tamper it. Like I want to break that tag which was tied in the baby hand. Then obviously that flux sensor will give an acceleration which will send a signal to the nearby alarm system or to the safety stops, right? This is one of the sensor which can be used in any equipment. If someone, on other cases, you've seen that one of the patient is trying to steal some bedsheet from the hospital, right? He is moving out of the hospital and the alarm is created. So there, I can use the potentiometers, right? The movement when any equipment is moved from one location to other location, then or it is moved, then this sensor will trigger a message. So that the triggering will maybe an alarm or a message SMS, or it sends a warning message to the nearby control stations. So these are the applications. You have to think the applications according to the healthcare industry. The sensor will do the same job. So whenever this flux sensor is tampered, it will create an alarm. Potentiometer, whenever it is moved, it will create an alarm. The accelerometer, when it was in the moving state, when the speed changes, then it creates an alarm. The ultrasonic sensor is able to measure the distance between the objects, right? So suppose I am keeping one object in one place, when someone is trying to move that from that particular place, if this sensor is placed, it will indicate, it will create an alarm, right? I can measure the distance it is moved. The gas sensor, any poisonous gas comes into the room, I can detect, I can create a alarm, right? So similarly, there are variety of sensors are used. The sensor basically monitors and give one message. Now, what to do with that alarm? That I have to decide based on my applications. For example, I told that baby safety band, when someone is trying to remove the band from the baby hand, it will create an alarm. When someone is taking the baby out of the room, then that band which was tied in the hand of the baby, when it moves to certain distance away from that location, it will create an alarm, right? So these are all the ideas which can be inculcated in the healthcare applications according to the sensors. Right. You see that here there are some healthcare sensors. Today we are in the pandemic situations. Everyone is measuring your heartbeat rate and blood glucose, that is oxygen level. So anything above 95 to 100, right? It is safety oxygen level in the blood, and your heart beat rate should be above 75, right? So if the such thing is there, I am safe. I am all right. I am not having any corona, right? So even myself are testing with this oxynometer every day, right? These are all this type of sensors which will measure your heartbeat rate, your oxygen concentration in the blood, and I am showing it in the LCD display. If required, this can be transmitted to a system and stored as a data, right? So that Max 30100 is a model of oximeter rate sensor which measures these parameters. Later in the presentation, I will show you how to develop an oximeter using the IoT components. And similarly, the human body temperature. These are the three parameters nowadays measured to monitor whether a patient is having corona or not, right? My temperature is monitored, my blood oxygen level is monitored, my heartbeat rate is monitored. This is the immediate thing, says whether I am healthy or I am not healthy. Then if I am healthy, it's okay. I let you permit that person inside the room or inside the campus. If I am not okay, then I have to go for a corona test, right? So this thing can be automated by Internet of Things. Okay, so I sensed the data, maybe using a oximeter or a pulse sensor or whatever the sensor I have. The sensor only can sense the environment, but I need to process it. So I need a microprocessor or a microcontroller. See this, there are three different types of microcontrollers: Arduino board, Raspberry, and Lily. What is the future of these Arduino boards? All things will do the same job, but the features varies. If you see that Arduino IDE, it is useful for this very simple applications. If you go for Raspberry Pi, it has its own operating system. You can install an operating system inside the Raspberry Pi, Raspbian. Like Raspbian is an OS. It has an external memory slot. You can see that you can connect your mouse, or you can connect your pen drives. All these USB slots are there, right? I can connect the internet cable through this slot. So more features, I can connect to the video, audio plugins. I can connect even my TV monitor screen, right? So it's similar to a computer, right? A mini computer. We say that credit card size computer. If you log into your screen, you can see that the OS is installed inside this microprocessor, and you can write a program whatever you want, just like what you write in your computer. I can even do a net programming inside this Raspberry Pi, but this is not possible in Arduino IDE. Arduino IDE is a simple program, simple microcontroller where I can write my codes. The memory is limited compared to Raspberry Pi. And for wearable technologies, so I want to put some sensors inside the body. I want to put a sensor in the shirt. I want to put a sensor in the shoe. Then I cannot go for a credit card size computer. I want to even small microcontrollers for doing my application. There comes 1 rupee coin size microcontroller called as Lily. So the Lily is commonly used for such applications. The wearable technology, you know that today that most of the things are wearable technology. I wear band, healthy band in my hand. It monitors my blood pressure. It monitors my glucose level or my heart beat rate and informs this data to the server. But for this, I cannot have a very big component inside in my hand. Like I can wear a band like my watch. Then the microcontroller has also to be small. So there comes the component like Lily, which is an reduced size microcontrollers. These are the different microcontrollers, microprocessor options with which you can develop your innovative ideas. Then I sensed the data, I processed my data using the microcontrollers, how to transmit it. Whether I need to transmit it to the nearby computer, or I need to transmit it to the web server, or I need to transmit to the mobile phone, right? So there comes the wireless modules. It may be a Zigbee module, which transmits up to a few meters in an indoor environment, like in the hospitals. Only that permission transmission should be happen within the hospital. Then I can go for the Zigbee networks that supports the transmission of the data within few meters. And if you want to go to the internet, you want to show the health records of the patient, which was monitored by the sensors in a server, I can use Wi-Fi modules. I can connect it to the internet, and the data sensed by the sensors are transmitted to the any cloud database. So in this case, we will see an example with the ThinkSpeak, which can able to store the data sensed by the sensors and also visualize the data. So we can visualize the data in the form of graphs and tables, right? I'm sensing the data for last 1 week. How I will see it? I need some visualization tools. For that, I need to transmit the data to the server. So these are done using this wireless module. Another is the GSM module, where you will put in your SIM card and you are integrating this GSM module with your microcontroller. Now that sense data are sent to our mobile phones. Right. I can send the command from my mobile phone to the sensors. So these are all done with these three components. I shown you what are the sensors which can be used, what are the microprocessor and microcontrollers which are used, and the wireless modules that can be used. And this is the environment, Arduino IDE. It's an open source where you can write your program, flash your program inside the Arduino board or Raspberry board. Now the system is ready, and the innovative ideas is up to you. Now, we will see a simple programming, how to connect a sensor with the Arduino board and see whether that sense data is coming fine or not, right? So if you go to the Arduino board, you can see there are a variety of pins. Particularly, you see here, these are all the pins related to that supply of voltage to the sensors. You want to supply the voltage. Here the sensor LM35, I'm using a temperature sensor. There are 3 probes. The first probe, I need to give the power supply. So I have to connect it to the probe 1 with any one of this pin, maybe this 5.5 volt pin. So the connection of this probe has to be done with this 5 volt. And the second one is the output. So the sensor senses the data, the voltage, the output is in terms of voltages, right? The output has to be given to the one of the pin, maybe an analog pin. I am using analog pin 0. So I'm connecting the one with the 5 volt power supply. I'm connecting the probe 2 with the analog pin, and the third pin is the ground. I am supplying this connecting with the ground, right? Now I will show a simple program. So I'm writing this program and fixing this 9600 is the baud rate. I am already enabled the input pin as 0. A0 is the pin name. This I am initializing here, and I'm converting that voltage to the temperature. You know that sensors will give output in terms of voltage, millivolts, right? So this is a formula for converting the voltage into the degree Celsius. And finally, I'm printing the value with a delay of 1000 milliseconds. When you load this program, you can see the output. So what is the temperature of your room, right? So the sensor sends something. It was connected with the microcontroller. The microcontroller able to process the sensor inputs, that is giving the inputs in terms of millivolt, that is voltages. So I have some formula for converting the voltage into temperature. This finally the temperature is shown in the screen, right? But in certain cases, I need to show in an LCD display in the device itself. Otherwise, I need to transmit this data to a server so that I can visualize it whenever it is required. You know that sensors are limited in terms of processing speed and also in the storage space. I cannot store large volume of data in the microcontroller or microprocessor. So I need to send this data to the cloud environment. So there comes the concept of ThinkSpeak, right? I need to connect to an cloud server, and my data, whatever I am sensing using the sensors, can be stored in the cloud environment. If you go for the healthcare applications, suppose I am monitoring the patient's heartbeat rate and the oxygen concentration level and the temperature of a corona patient in the ward. I am doing it for every half an hour or every 1 hour. This record has to be stored. So no, that then I can use my IoT components, the project what I am showing you. I can fix it in the hand of the patient, and every half an hour the data is recorded and it is stored in the server. So the doctor, whenever you want to assess the progress of the patient, you can go to that particular patient records in the server, and I can see that whether the improvement has happened in that patient or not, right? Similarly, the first example what I shown is the simple temperature sensor. Second example, I am using the pulse oximeter. So what you are nowadays familiar, right? Everyone is checking the pulse oximeter to know whether my oxygen level is okay or my heartbeat rate is okay, right? The same thing, what I told. I can connect it with the microcontroller. I can display using the LCD display, or I can connect to the ThinkSpeak website where I can monitor my data. You can see this website where there are the source codes for doing this project is available. I given in that bottom of the slide. You go to this website, there are a detailed source code along with the explanation is given, how to connect the hardware equipments, the sample code is given. You can develop this project, right? This is the want of day today, right? Today, there is a lack of doctors and nurses to monitor the corona patients. Whether I can use such projects in hospitals, then it will be a great use for the nation. But there are this product has to be developed. Someone has to do this, develop this. That is the need. See? It shows my oxygen percentage is 98, and my heartbeat rate is 76. That is 76 beats per minute. Now, this is the first case where I can see my data in the screen. Next case is I want to store this data continuously in the cloud so that it can be used later for evaluating that patient's improvement in health condition, right? Now I need to go for a cloud service, integrating the cloud service with the Internet of Things. First, we seen about how to integrate sensors with microcontrollers. Now I am going to show how to integrate the cloud with the microcontrollers so that the sense data will be stored in the server and which can be used for the future references. This is the ThinkSpeak the website. You can create a free login with this website for storing your data which was sent by your sensors. You can see that in the bottom I am given the website link where you can find how to create an account in the ThinkSpeak. Next, if you once you log into the ThinkSpeak website, you can find a button called this new channel. You click this button, it will ask for what is the channel name, what you want to create, what is the field you are going to transmit from your sensor. So here I am creating IoT, Wi-Fi, and one field called as temperature, right? So once I created a field, there is an API key is generated for my channel. This key I will be using in my program, which I am programming in the Arduino IDE. I have to give this key in my code so that this website will be connected to the microcontroller. Right, the detailed step you can see in that website. Anyhow, I am explaining how the step-by-step process of how to do it. Now I want to create the setup of the equipments. So you already know how I connected the temperature sensor with the microcontroller. I connected the input probe with the A0 and the output probe with the 5-volt supply and the ground probe, right? And similarly, I want to connect with the cloud. I need an Wi-Fi module connecting this equipment with the internet. I use the ESP Wi-Fi module. This module, you can see the description here. So these are the pins which was connected here. You see that this is the ground, which I am connecting it to the ground of the pin, and the transmission line pin and the receiving pin. Right, I am transmitting some data from the microcontroller. It will go through that this pin, and some signal which was received from the external source will be coming to this. So I am connecting it to the respective pins. Right, I should know which pin I have connected. Then I can name this pin in my program. So I am connecting one temperature sensor. I am connecting the microcontroller, that is a Wi-Fi module with the microcontroller. Now I need to code the program inside this memory, right? It's a sample code. I already know that what is my application API key, right? This program you can download it from this website. The code is already available. So only thing what you need to do is you need to update your API key what you have created, right? The API key was the key which I shown in the previous screen, which you have created in the ThinkSpeak website. This thing will be copied to your code here. Then I need to give the username and password of my Wi-Fi, because I am connecting a Wi-Fi module here, right? Well, so if this Wi-Fi module is connected, if it has to be given with the username and password for connecting the Wi-Fi module. So that particular part of the code can be changed. All other things are same, and you can find a detailed explanation of line by line what is the use of this code, why this code is given. The only thing what you need to change in your program is your API key which was generated, and your Wi-Fi username and password, right? Now, after connecting it, I load the program inside the microcontroller. I run the program. What will happen? You go to the ThinkSpeak website. You can go to the private view. You can see a screen comes with the temperature value every 5 seconds according to your program. It will be coming in the screen, and it is visualizing, and you can download it from these options. Right, the data can be downloaded as an Excel sheet. Data import and export options will be there. It will be stored in the Excel sheet. Here I am using only one field, is a temperature, and whenever the data is received, it will be added to that graph, and I can get a graph of the particular thing which was sensed by the sensor. Now you think in terms of your blood glucose level, your temperature, your what do you say, that heartbeat rate, right? These parameters, if I am storing in the cloud, Then the channel name is the patient name, and I can see that for last 1 week, if we are in the quarantine period or 2 weeks in the quarantine period, how his temperature and how his blood glucose level has been increased or decreased, at what time it is increased, whether now he can be discharged. All these things can be analyzed using my project. Hope you understood how the things works, right? Maybe the technology is same, but the application varies according to the requirement. I am fitting it with the current situation, right? So maybe can be for an heart patient, or it may be for a sugar patient, or whoever may be the patient, whatever may be the parameter I want to monitor, I can do it with the same type of technology. The sensor may vary, that's all. Right. So the temperature sensor measure temperature. You go to oximeter, if it high, then it will measure the oxygen level. So you go to the blood glucose level temperature sensors, then it will show the glucose level of your blood. Whatever maybe it is required according, it's up to you to decide, or the domain people who is going to give the project for you. Right? Hope you understood this idea. Any doubt in this? I can proceed further. Yeah. So far we have, am I audible or? Hello? Hello?
Audible, sir, audible.
Okay, right, thank you. So whenever, if anyone required, you can raise your hand or you can interrupt me at any time. So far we have discussed about the sensors, the microprocessors and microcontrollers, then how to connect a sensor to an Arduino board, how to monitor the temperature values, then now I shown how to integrate the IoT with the cloud environment using ThinkSpeak. Now we'll see about how to control the equipment, remote equipment, using my mobile phone, right? I want to switch on or switch off my equipments, maybe an healthcare equipment or any other equipments, of using my mobile phone without going there, right? Then I am demonstrating with an app called this Blink app. You can download the Blink app in the Google Play Store. So the app will look something like this. You create your account. It will ask for the username and password, the email ID, your email ID. You can give your email ID. Now you create a new project in this app. And in that project, it asks detail what is the microcontroller you are going to use. So I am giving Arduino Uno, right? Arduino Uno is a microcontroller through which I am developing my project. And it is asking what type of device, that is the network you are using. I'm using a Wi-Fi. Or it can be an USB or maybe whatever maybe you want. You can do GSM, whatever. So since we are using the Wi-Fi module in our project, I am giving Wi-Fi. The other options you can see, USB, GSM, many things are there. Once I give OK, then an authentication code will be sent to your registered email ID. That code I have to use in my my project, like what you use in the API key. Here it sends an authenticated code. Here it will come into your email ID, registered email. You can see in the screen, authentication token, call this authentication token. This token will come to your email ID. Now, the next step, I need to create one button. So I am selecting one button. I have to select which pin I want to activate it in the microcontroller. I am selecting the pin number 13. So this is the pin number which I am giving it. Any devices connected to that particular pin will be activated. For example, I am connecting a relay with the pin number 13 in my Arduino board. That relay is connected to a tube light or a fan. Then if I press this button, what will happen? It sends a signal to the microcontroller. That signal is activating the pin number 13. So when the pin number 13 is activated, this pin number 13 is connected to the relay input. Now the relay is on. So any equipment which is connected to that relay will now is in the switch on state. For example, your light, your maybe a fan, whatever may be the case. So this you can see how the hardware setup is there. So here I am using the Arduino board. I am using my Wi-Fi module. I shown you how to connect the Wi-Fi module earlier. So what I am doing is I am connecting the relay. The relay, you know, it is like a switch. It has the input, output, and the ground. So the input which I am giving is the 13, pin number 13. Right. If I use the button, the 2 or 3 different buttons, say that D14, D15, D16, I can create this is D4, this is D13, and this is D14, and this is D15, right? So 3 different pins is going to be activated when that particular button is pressed. Now this relay will be activated, and any device which is connected to relay will get power supply. So here the light is on. If I click D14 pin, that button, it will go to the fan, and D15 will go to the tube light, right? So this is the sample code. You can see this sample code in this following website. The only thing what you need to do, the changes is the authentication token, which was you seen that it was generated here. No, you have to give this token number in your code, right? Then your Wi-Fi username and password, you run your program. It's a simple program. So whatever may be the connection I shown you, very simple connection. These 3 relays are connected. In this 3 relay, I am one side that power supply you have that in that for tube light or fan, I am connecting a wire. No, that the wire has two wires. One is a black color wire and one is a red color wire. One is a ground and one is the input for that wire. So I will connect that ground to this here and the input to the other end, right? So whenever the button is pressed, the relay will be on, and this power supply will be entering the relay and it will be supplied to the tube light. So this is the concept of controlling the equipments remotely. Now here I need to stop and I need to play a video of this so that you can understand better. I have 2 videos. One is this ThinkSpeak website, how to connect the ThinkSpeak website with the Arduino board. This is the project done in our IoT lab in the Aarupadai Institute of Technology, which won the Vishwakarma Chakra Award in 2018. There we are using an energy meter, monitoring the energy consumption of that particular energy meter, storing it in the cloud. There they are using the ThinkSpeak website. And another project is, it's not done by us, anyhow it shows what I have demonstrated, I have discussed so far, right? So these 2 videos, if you see, you can understand how this code is working. First, I will play the video of this Blink app. Then I will play the video of that ThinkSpeak website. It is audible. The video is audible and clear to you?
Yes, sir.
Participants?
Yes, sir.
Thank you.
Audible, sir. Audible.
The audio is clear now? Hello? Hello?
Sir, all is clear now. Sir?
The audio is okay?
Yes, sir. Now it's okay, sir.
Oh, okay, okay, thank you.
Last 5 minutes we have some discussions. Sir, audio of the player, sir. Video play is not okay, sir.
Hello?
Audio of the play. You played some video, no?
Yes, yes.
But we can't get the
The volume is not is clear for you.
Yeah. Yes,
Is this
sir.
for same for all the peoples or few peoples?
In
Depends
chat
on-
box, no, sir, for all the peoples.
Okay, okay. I will close it and I will try to play it again.
Okay, sir.
It
Okay, sir.
depends on the internet connection of the users.
Okay, sir. We can't get that audio, sorry, video.
Yeah, yeah. It may be in the same,
Sir,
not in the same synchronization. Or I will try to play with some other player.
Jaichandran, sir. Sir,
Yes, madam.
last 5 minutes you played one video, no?
Yes.
In the video, any sound or any special?
Yes, the sound is there. It is not audible to you?
No, sir. You played one video, that video is not audible.
Try to play again.
Okay, sir.
Anyhow, you can watch the video. The sound is not necessary. You can see that things.
Okay, sir. Okay, sir. Then it's okay, sir.
So in this case, you have to select according to your project, right? Whether you are using the Arduino board or you are using Raspberry board, whatever, according to your project, you have to select. So in that your project, they are using Node MCU instead of Arduino IDE. So they are selecting Node MCU. Our case, it is Arduino. So you have to select one of these components. Okay, now I hope you understood how this blink app able to control the device. So you can think in terms of healthcare applications. Suppose I need to monitor the patient's health condition. I can switch on the sensor remotely and I can get the parameter. So the body of the patient is already fitted with the sensors for monitoring the particular condition. Suppose I want to monitor the oxygen level, blood oxygen level of the patient who was admitted in the corona ward. Now I need not to go to that patient. I already fitted this equipment in his hand, and this equipment is connected with my mobile phone. I can switch on the system and I can get the value from my in my phone, right? Or I can store it in the cloud. So this is the terminology how I can change these applications, right? The way of working is same, but how you are going to use it, that depends on the situation and the project. Okay, am I audible now?
Yes, sir, you're audible.
But only video is the problem, right? You are not able
Yes,
to hear.
sir. Yes,
The
sir.
previous videos you are able to hear, right?
No, sir. For the last two
See?
videos, we can see
Okay.
that video. That's why we didn't hear any voice from that video.
Okay. So I will continue with my other modules like in the machine learning. I think we can play the remaining videos at the last if the time permits. I have one more video of how this ThinkSpeak is working, right? This is a project done by in our IoT lab. Anyhow, that I will play in the end since the
Okay,
quality
sir.
of connection is not so good. I will go with the presentation. Now, so far we've seen about the sensors, microcontrollers,
Excuse me, sir.
microprocessor. Yeah.
Sorry for the disturbance. Sir, can you maximize your slide?
Yes.
Thank you, sir.
Yeah. Is it
Now it's
okay?
okay, sir. Okay, sir.
Yeah. So far we've seen about the sensors, the microcontroller, the microprocessors, and the Wi-Fi wireless modules, how this is used in building the IoT components, and how the technology can be applied in the healthcare industry, like maybe monitoring the patient history in the cloud service, or controlling the equipments remotely using your mobile phone. So these are the things what the technology, how to implement it, we've seen it. The third challenge, one of the important challenge, what we've seen is I have the patient records stored in my computers, right? Today, most of the hospitals are electronic health records. They collect the patient's record, stored in the computer. I have the record of all the patients, maybe in the, maybe in gigabytes, right? But whether I'm using this for any purpose, maybe I'm using it for storing the details, address, and other things. Other than this, is any usage? This record can be used for any purpose. Can I do a research with these records? Yes, certainly. There's one of the emerging area which is coming is machine learning and the deep learning, where you are going to train the algorithm with your data set, and that machine will become an intelligent system. If you give any new input, I will say whether that particular input is belong to which category, right? It's like an experienced doctor. How a doctor, by seeing the pulse of the patient, you can able to predict what is the disease he's having, right? Similarly, because he has checked the pulse of the patient for last 20 years, he knows the knowledge he generated based on his experience. Similarly, a machine can be able to learn from itself, from the data which you are given as an input. So the definitions is also say the same, able to learn from the data which you are going to give without programming. The word is important, without programming. I'm not going to program anything. I'm only give to the data to that algorithm. The algorithm will learn what is the parameters. For example, simple case I'm taking, your diabetic patient and non-diabetic patient. So a person is called as a normal person when he has a blood sugar level in fasting is less than equal to 100 mg per dl, right? So the sugar level is say that 100 before taking breakfast, that person is normal. And after taking breakfast, 1 hour or 2 hour after your breakfast, if you go and check it, if it is less than or equal to 140, we say that this person does not have any sugar, right? If this is not the case, then we say that is a diabetic patient, right? This is a well-known definition, everyone knows, but the machine, how it knows, right? I'm not writing a program with an if-else statement saying that if the patient record is less than or equal to 100, he is non-diabetic, yes, he is diabetic. No, I'm not writing a program. I'm just giving the input of the some patients of normal sugar level and the diabetic sugar level. And maybe an 100 data of normal blood pressure level and 100 data of the diabetic patient's blood pressure, blood sugar level. Now, from this data, the machine will come to a conclusion that if this is the threshold level, below which we say that the person is normal, above which it is the, we say that is a diabetic. You understood what is machine learning? I am not writing a program with an if-else statement. Instead, I give a set of data to the machine. The machine will understand from the data who is diabetic and who is not diabetic, right? So this knowledge, the machine able to generate from itself. This can be applied to any critical problems. So for example, I want to analyze the X-ray images, want to find out whether, say that breast cancer, we have three states like the normal, malignant and benign, right? So when the patient is benign, the tumor will be small and it does not spread to the nearby cells. When the tumor is spreading to nearby cells, we say that is malignant breast cancer. That is harmful, right? How the machine, the patient here, normally the doctor will go through this X-ray images, he will identify it, right? But the machine can learn from the experience, the images you given us a feed it as an input, which image is falling under the normal case, which image is falling under the benign case, and which image is falling under malignant case. The same thing in terms of diabetic. I'm just leaving it for your understanding with a simple case. So, very complex problems where the human analysis is not possible or it takes very time consuming, there we can go for machine learning applications or the deep learning applications where the machine can take better decision compared to the humans, right? So we have two types of machine learning. We generally have supervised learning, unsupervised learning, and reinforcement learning is the third category that learns from experience. In supervised learning, the definition is algorithm is trained by an input data with an output. That means this is the value, this is the output. For example, the blood pressure sugar level is 80 before fasting and blood sugar level is 110 before fasting, is BP level is so much, then the output is 0. That means 0 here is non-diabetic. Second data set contains the blood sugar level fasting is 120. The blood sugar level of the patient postprandial, that is after breakfast after 2 hours, it is 180, and his blood sugar BP level is 100. Then we say that that patient is a diabetic, right? So this is the called as a label data. I will give the input. What is the output also I will say. This is the condition. This is the output. This is the condition. This is the output. Maybe an positive case or negative case. So this is called as label data. This data is given as an input to that machine. This is called as supervised learning. On another case, I will give only input. I will not say the decision. Right? I will give the diabetic value of the blood sugar level value of the patient, BP value of the patient, and diabetic pediatric function value of the patient, but I will not say whether that patient is diabetic or not. The machine itself will learn. That is called as unsupervised learning. So there are two categories. One is supervised learning, training the machine with the label data set. Label data sets means the input and output are defined. The second case is unsupervised learning. I am training the data with unlabeled data. That means output is not defined. I am giving only input. I am not saying whether what is the output for that particular input. So, for example, supervised learning regression. Regression, I can able to predict the temperature, tomorrow's temperature, based on the previous input which I have received. I have collected the data of the temperature of the city for last 1 year. Now, what will be the temperature of the city tomorrow? So this is called as a regression. That is a real-time value sensor value. It's a continuous number. And another is the classification task. I will say yes or no only. I will not give any particular numeric value. Like tomorrow it will be a rainy, or it will be hot, or it will be an overcast, right? So I can forecast the climatic condition, whether it will be hot or cold. I will not say whether what is the temperature. This is called classification task. So these two categories comes under supervised learning. And the third, the unsupervised is called as clustering. For example, I am given the basket of fruits. The system can able to classify it according to the color, and but it does not know this is belongs to apple, this is belongs to mango, right? See, similar elements are grouped together because I am not given what is red color, what is yellow color. If I give red color is apple and if yellow color is mango, then it is called the supervised learning. But here I am not saying which one is mango and which one is apple or which one is cherry, right? The machine itself classifies the groups according to its color and its appearance, right? Then it is called as unsupervised learning. For example, here in this case, I am giving birds, animals, and other things. Based upon its structure, it is classifying the birds as one group, fishes as one group, and animals as the other group. But it does not give its name because I have not labeled it. Here I am labeled it. Here I am not labeled it. So this is the general understanding of supervised learning and unsupervised learning. For example, now we will see about detection and classification of diabetes using machine learning algorithms. So there are three types of diabetes. You know that type 1 diabetes, type 2 diabetes, and the gestational diabetes. Type 1 diabetes, the body does not produce insulin, and because of that, blood glucose level will increase. You know that the glucose level in the blood increases, we call that it's a diabetic condition. Because the glucose is the thing which converts the carbohydrates into energy, right? If it is not proper, then it is not converted, then the blood glucose level will be increasing. Insulin is the thing which converts the carbohydrates into energy. If the insulin is not secreted by the body, what will happen? The energy, the carbohydrates will not be converted into energy. Obviously, the blood glucose level will increase. This is called as type 1 diabetic condition. There is no insulin secretion in the body. Because of that, your body blood sugar level is increased. So whether you have to put insulin through your needle or whatever may be that, right? The second case, the body produces insulin, but the body does not have a capacity to convert the glucose, the carbohydrates into energy. The insulin is available in the body, but the body will not use it. It lost its ability to use the insulin. The insulin is an hormone which is responsible for converting the carbohydrates into energy. If the insulin is not there, this process will not happen. And that's called as a type 1 diabetes. And the second case is the type 2 diabetes, where the insulin is segregated, but the body is not using the insulin. And because of this, your blood glucose level is increased. This is called as type 2 diabetes. The second case is the gestational diabetes. This is common for the pregnant ladies until they are now, once they get pregnanted, they will face the type 2 diabetes. So this is called as the gestational diabetes. So these are the three common types of diabetes. I'm going to train a machine learning algorithm with a normal patient's data set and diabetic patient's data set, and the machine able to recognize it, who is diabetic and who is not diabetic, right? So I have downloaded the PIMA Indian diabetes data set because I want to train my machine. I need to get the patient's data, right? I have to get it from the hospital or from some source. So the machine learning repository already uploaded the diabetic and non-diabetic patients data set. You can Google it, you can get this data set. There are 768 rows of data with following fields. So these are the fields from which the doctor can identify whether the patient is a diabetic patient or a non-diabetic patient. So they will check the blood glucose level, they will check the blood pressure, they will check the insulin. From the insulin only, they will be able to say that whether you are type 1, type 2 or whatever may be. The body mass index, the height weight of the person, Then the diabetic pediatric function, which is called as your ancestors history, whether your father and mother has the diabetic or not, and such things. And your age is also one of the important factor. And pregnancy, for detecting the gestational diabetes, you need to know whether that woman was pregnant or not. So, and then the skin thickness is also one of the parameter. And finally, the result, whether the person is diabetic or not diabetic. That is the data which was given in the data set. Right. If you want, I can open and show the data set, but you understand that this is the 8 fields, 9 fields. 8 fields are the input fields. We call as the independent variables, and Y is the output, which says whether diabetic or non-diabetic. Here, 0 used to indicate is normal person, and 1 is used to indicate the diabetic patient. So till now you understood? Hello?
Yes, sir.
Yeah. So now these are the different types of algorithms used in the machine learning, because when I am applying the algorithm, I should know which algorithm I am using. It will be better to detect the disease, right? So linear regression, logistic regression, naive Bayes, random forest, support vector machine, decision tree, k nearest neighbor, convolution neural networks. These are the well-known algorithms, machine learning algorithms that can be used to train a model. So these are the different principles. We will see one by one what is these algorithms, and I will show a program of one of the linear regression method. And finally, we will come to a conclusion which algorithm is better to detect the disease in case of diabetes. So the linear regression algorithm, we have it's a mathematical equation y is equal to ax plus b, the simple algorithm where the x is the independent variable and y is the dependent variable. If you see in terms of diabetic condition, x is the blood pressure level, glucose, that BP, pediatric function, the 8 parameters, what you see, no? Other than the 9th one. All these things are the independent parameters, and that is the input. It's called as the x. And y is the output, that is the whether it is diabetic or not diabetic. So based upon the x value, and a and b are some constant values, which will influence that value. So based on that, I will decide whether he is a diabetic or non-diabetic. So we are using the multiple regression since there are 8 different parameters. I'm using x1, x2, x3. The equation will be looking like that. We call this a multiple regression. So what is x1? Blood sugar level, x2 blood pressure, something like this, right? So this the equation is going to be converted like this, but you no need to create an algorithm, right? There are built-in algorithms available in the machine learning library, which you can use. Just you need to give the input of the data to that library so that it can able to train itself. Now I am, once I trained the algorithm, I need to test it whether the algorithm is good or not. So I am going to train the algorithm with 590 rows of data, right? I have initially shown that 768, I split it into training data and testing data. Training data with 590 rows with 8 fields as the input field and 1 as the output field. I am using it for trying the algorithm, like teaching the algorithm. So this is the input. From that you learn from yourself who is diabetic and who is not diabetic, right? And testing data, I will give 178 data, which includes 64 diabetic patients and 114 normal patients record. Now the machine has to tell who is diabetic and who is not diabetic, right? If it is told rightly, then that algorithm is an effective algorithm. Else it is not an effective algorithm, right? Like a teacher teaches the students. There are 60 students in the class. Like this, I teach them what is ball, what is apple, and some 10 elements. Now I asking one by one. There are 8 students, 8 algorithms. My first algorithm, I am saying that showing an apple and asking what is it. Out of 8 algorithms, 7 people told it is apple and one guy say it is a mango. Then that is called as wrong identification. So this is how I am going to evaluate it. So I am just training the data, that is teaching the algorithm. Next, I am going to test the algorithm with sample data without output. That's why here it is 7 field and here it is 6 field. The 7th field, it has to say whether it is diabetic or non-diabetic. If it tells all the 64 diabetic patients correctly, then it is 100% efficient. Otherwise, the efficiency depends upon how much it is correctly identified, right? Now we'll see with all these 7 algorithms, which one is better, right? So some things how these machine learning algorithms are evaluated. So these are the steps in machine learning. First, you have to import the library files and training data set. Then you need to import the machine learning model. I am showing it only with one example because there is no time. A linear regression algorithm. I am downloading this algorithm from the scikit-learn library and then importing the test data. Then the training the algorithm with the trained imported training data. Finally, test the data with the trained algorithm. Predicting the output of the test data using the trained linear regression model, displays the predicted outcome and compare the predicted outcome with the actual outcome. That 178 data, I already know what is output, right? So I will check whether the machine said one is right or wrong. From that, I can able to say that whether that algorithm is efficient or not. So these are the parameters which are used for evaluating the algorithm. True positive sense means the patient is diabetic. The machine predicted he is diabetic. That is called as true positive. You understood? The patient is a diabetic patient. I know the result, but I ask the machine whether he is a diabetic patient or not diabetic patient. If the machine says he is a diabetic patient, then it is called as true positive. Second is true negative. The patient is not a diabetic patient. He is a normal patient. That I know. Now I ask the machine whether that patient is a diabetic patient or non-diabetic patient. The machine says he is not. He is a normal person. Now it is predicted rightly. That's called as true negative. Rightly predicted the negative things. False positive. That means the person is not a normal person, but machine say he is a diabetic person. It's called as false positive. Right. Second case is the person is diabetic and the machine said is a normal person. So false negative, right? So this accuracy precision formula we will see in the screen. Now I am using the Jupyter notebook. I am importing the library files, the pandas and the numerical Python. These are the files which are necessary for your process. Then I am importing the Excel sheet, which has 768, that 568 data, no, with 8 fields, that is input and output fields. This is the training data which I am going to give to the machine for learning. So you can see that in the screen, the parameters and output is given here. For this value is a diabetic, 1 means diabetic. For this value is not a diabetic, 0. So similarly, there are some 568 rows are there. I am given as the input. I am downloading this input, right? Second, this input I need to give us an input is this machine learning model to train. So I'm downloading the machine learning model from the scikit-learn library. Here you can see that linear regression model. So import linear regression model from scikit-learn library linear model. So I am importing that linear regression model and I am naming it as LNR. Now I am fitting that linear regression model with the training data. X-train data. X-train data means what? This is the train data. Train data here. Train data drop output means you train the data with all the fields except this particular column output. Drop output. That means without output, I am training all the data in the X coordinate. And in Y coordinate, I train only the output data, not the remaining data. You understood? X train means I am training the training data without output. That is X and Y coordinate is only the output. So here from pregnancy to age will be trained in the X case, and the output will be trained in the Y case. Now I am fitting the X train and Y train linear fit. So now the algorithm is learned from my input for which X value, what is the Y value. So it is able to come up with some equation. Is called as a trained model. This is called as the trained model. Able to see this line, X train and Y train data. X train means from here to here. Y train means this particular column. So for this value, what is the Y? For this value, what is the Y? Right? Now I need to test the algorithm. I trained the algorithm. Now I need to test the algorithm with the sample data. You already know that we have 178 sample data without output. You can see that I have the fields, 8 fields without output field. Now the algorithm has to tell me whether what is the output. Right? I have the answer already, but the algorithm has to give 1 or 0 value for this particular thing. Now I am downloading the test data. I am fitting this test data. I am giving this data as an input to the already trained algorithm. This is the algorithm, right? So you are getting some value which was round off to 0 or 1. 0 means non-diabetic, 1 is diabetic. I am getting the value output. Now I am printing it. See, for your test data, it is given the value 1, 0, 0, 1, some value. 0 means non-diabetic, 1 means diabetic. For your test data, it is said the answer. Now you have to check whether it is rightly said or wrongly said. For that, I am comparing with the actual data. I know this is the result, which is the original result. Sorry. And this is the result which was given by the machine. So this is called as true positive. The original result is 1. The predicted result is also 1. The original result is 0. The predicted result is also 0. Right? It's called as true negative. So this is the definition for evaluating your algorithm. True positive is sense the diabetic patient is correctly predicted as a diabetic patient. True negative sense a non-diabetic patient is correctly predicted as a non-diabetic. False negative sense the diabetic patient is wrongly predicted as a non-diabetic. False positive sense non-diabetic patient is wrongly predicted as a diabetic patient. Now, with this, I can calculate the accuracy, recall, and precision and F measure. So with these parameters, I can say whether the algorithm is a good algorithm or not. Right. So these 4 parameters plus these 4 parameters. So the true positive is high, true negative high means the algorithm is good. The false negative, true positive and for true negative is high, the algorithm is good because it rightly said. If false positive and false negative is high, then the algorithm is not saying correctly. It was saying wrongly. It's saying that they have a non-diabetic patient as a diabetic patient and a diabetic patient is a non-diabetic patient. So this can be, the accuracy may be anything above 90% is good. So you will see one by one how the algorithm is performing. So you can see this is the formula, the code for coming that check that true positive and true negatives. I am getting the following score. 37 items. So in that 64, totally 64 are diabetic patients and 104 are non-diabetic patients. That is the original record. Here, out of that 64, 37 is identified rightly. 37 is the false, true positive, and 27 is the false negative. And out of 114, normal patient, 104 is rightly recognized, that is 2 negative, and 10 is wrongly recognized. You understood what is the difference? So I given 178 data set. In that, 64 is the diabetic patient data set and 114 is a normal patient data set. So in that 64, 37 is rightly said as a diabetic patient. So remaining thing is false negative. That is 37 plus 27 is 64, right? So this 27 is wrongly predicted. Here 104 plus 10, 114. That is out of 114, 104 is wrongly rightly predicted as it is a normal patient. 10 was predicted, normal patient is predicted as diabetic. So if you calculate the accuracy, F score and recall precision according to the formula, you can see this percentage, right? It was showing 79%. So what will be the percentage for remaining algorithms? Then only I can say which algorithm I can apply to my machine to predict the disease. With one algorithm, I cannot say that who is the better person. Now I have to examine all the 8 algorithms. Which one is giving more percentage? Then that algorithm is the better algorithm. So first algorithm is seen as the linear regression. Second algorithm is logistic regression. This is a special case of linear regression algorithm. Only that it uses log fit function for y, right? That is the only difference between the linear regression and logistic regression. Y is equal to ax plus b. I am using that equation. I am using a log fit for y instead of simply y. So I am using a Gaussian distribution for linear regression, and for logistic regression I am using a binomial distribution function. So this is the two difference between these two functions. Second, third algorithm is the naive-Bayes algorithm. So naive-Bayes algorithm is based on the Bayes theorem. What is the Bayes theorem? So you can see in the screen. Probability of A divided by B is equal to probability of B by A, P of A and P of B. So A and B are the events, and A probability of A by B is likelihood of A occur given B is true. Probability of B by A is a likelihood of B occurs given A is true. And P of A and P of B are the probabilities of A and B respectively. So this is the definition of the Bayes theorem. But I not understood. I am not clear what is this. The question comes into the mind. Then we need to go for an example. What is Bayes theorem? So for example, I am taking one data set. I will explain the Bayes theorem with this data set. So in this data set, I have the weather condition and the play. So is this the weather condition, whether I can play the game or not? It's like a cricket. The umpire has to decide whether to allow the players to play or not. If it is rain, whether I can play or not. If it is sunny, whether I can play or not. It is an overcast, it is a play or not. அதாவது என்ன சொல்லலாம்னா மழை வருது, வெயில் அடிக்குது, மேகமூட்டமா இருக்கு. இதுதான் கண்டிஷன். ரெய்னி, சன்னி, ஓவர்காஸ்ட். ஸோ இது வந்து பிளே பண்ற டிசிஷன் வந்து எஸ் ஆர் நோன் டேட்டா செட்ல கொடுத்துறாங்க. I have some 14 data, 14 climatic conditions with the various decision taken by the umpires previously. Right, I am training the data set with this training data. What is the thing I am getting? Overcast with no. எத்தனை இருக்கு இந்த டேபிள்ல? Overcast with no ஏதாவது இருக்கா? இல்ல, 0. Overcast with yes எத்தனை இருக்கு? Overcast with yes 5 இருக்கு. 1 2 3 4 5 கரெக்ட்டுங்களா? 5 data. 5 overcast with the condition yes. So overcast no condition 0, overcast 5 condition yes. Rainy no condition, rainy with no, how many are them? 2, only 2. Rainy with yes 2. Sunny with no 1 2. Sunny with yes 3. So இதுதான் வந்து summary of the output. Now I am applying the Bayes theorem. Here yes is A and sunny is B. Right, this is the formula. You can think right. So according to the formula, I am writing it. P S divided by sunny and P sunny by S, P into P S divided by P of Sunny. So P Sunny by S means the condition you can check. What is the condition? 3. Sunny, yes. So 3 divided by how much? 5. So total Sunny is 5. Can you able to hear me? Hello?
Yes, sir. Yes, sir. Yes,
Yeah.
sir.
Yes.
Yeah, yes.
So you are getting this value and P of S 0.71 because S condition I am having how much? 10. But total is 14, including no. So 10 divided by 14, 0.71. Similarly, so P of S divided by P of Sunny 0.3 into 0.71, 0.31. Similarly, no condition. It is getting the output of 0.41. Out of this thing, this is the highest. So I can say the decision when the Sunny you can play, when the Sunny you can play the game. Understood? PS Sunny means 0.60. P no Sunny is 0.41. So yes is the highest probability. So when the Sunny you can play because Sunny has more value. Yes has more value than no. If no has more value than yes, you cannot. The decision is you cannot play. If we go for rain, then the no will be more. So these are all calculated based on the previous data set which I used for training. This only decides the output. That's called training data set. For your understanding, I am using this. The second is the fourth algorithm is the random forest. The word itself says that I am taking the input randomly and I am creating a tree. Suppose I have 8 parameters. One is blood pressure. I am taking the tree, blood pressure tree, below 100, above 100. Before this for prandial condition. Tree 2, blood pressure, postprandial, below 140, above 140. Like this, for each category, I will have a subtree. For each thing, I have come up a prediction. And I will average the prediction. I will say whether that particular patient is a diabetic or non-diabetic. So it will create a subset of tree from the training data set. So this is all not possible with the hand. That's why we are going for machine learning algorithm. With some thousands of data, you are going to draw a tree for each parameter, then it will become mad. But machines will do it faster. Support vector machine, you know that it creates an hyperplane between the two classes of data set. So what is the maximum margin and minimum margin level for the negative hyperplane and positive hyperplane? Negative hyperplane is a normal diabetic patient. Positive hyperplane means the patient is shown positive, that is 1 or 0. And decision tree is another algorithm where it will create a tree-like structure with the available data set. Here it is not random. It will create a complete tree structure. You can see that whether I can play or not play. So what is the play condition? When it is overcast, I can play. When it is sunny, when there is no wind, I can play. If there is a wind, I cannot play. The rainy, when there is the humidity is less, I can play. When the humidity is more, I cannot play. Right? So this is the condition based on which the decision will be arrived. So it creates a table based on your training data. And another is K nearest neighbor. When I am giving a new input for predicting, I will find out the nearest elements to that particular input, and I will find the distance between that new element with that nearest element. Here K is equal to 1 means that is the only one element near to this element. K is 3 means there are 3 elements near to this element, and 5 I will find out the distance between these 3 elements. To which element it was distance, then it is categorized that this element belongs to this class. So based on your friends, I will decide what is your character. something like that. உன் நண்பன் யார் நீ சொல்ல நான் உன்னை பத்தி சொல்றேன் அப்படின்னு சொல்றாங்கல்ல, அதே தான் அது. சிம்பிளா சொல்லணும்னா K nearest neighbor, based on your neighbor I will categorize you whether you are a good boy or a bad boy. You understood? That's the simple definition for K nearest neighbor. And another is the convolution neural networks. It is usually used for image processing application. What I will do is I will give the image as the input to the algorithm. I have the input layer and multiple hidden layers, and finally the output layer. The pixels of the images are fed into the system, and the pixels are converted into vectors, and from that vectors I will come up with a value. Based on the value I will say whether that is a bird or an animal or whatever may be. So each element has its own vector value, and I will come up with a mathematical equation for each animal. So whenever I trained a model with different figures, suppose I trained a model with a figure of a bird, I trained a model with a figure of an animal, I trained a bird model with the figure of a fish. Now I have an equation with an output value with the fish. There is some different type of value I will obtain. For birds, the output will be something different, and for animals, the output will be something different. When I give a new figure, say that one figure of a peacock, then it will come up with an output value which matches with the trained value. So then it will decide to under which category it falls. Understood? Like what we seen in that nearest neighbor, right? So each model will learn something from the pixel values. So like that, if a bird has a feather, it has a beak, something like the 2 legs. An animal has bigger in size, it has 4 legs. Some features it will learn, and it will be converted into numerical value. So whenever a new input is given, it will check for that features, and it will find out to which it was matching, and it say that it's 90% matching with the bird, only 30% matching with the animal, something like that. So I can apply this for training the breast cancer. You see in the figure, there are the images, X-ray images of the breast cancer. This is the normal image. This is the breast cancer benign case, that is the beginning case. It is not harmful. The second stage is the malignant breast cancer. That means the breast cancer is spreading to the nearby cells. You can see here the tumor is there, but the remaining portions is not affected. Here the tumor is there, but it was spreaded. So the image, if the machine learning is trained with this type of images, we cannot train it with 1 or 2 images. I need hundreds of images. Then when you give a new input image, it will say whether this images falls under the malignant category or benign category or a normal category. I can classify it. Similarly, diabetic retinopathy, the eye, diabetic retinopathy is a condition where the cells, that blood cells in the eye will be bleeding because of the diabetic condition. So you see that the normal eye retina of the human, if a person has a diabetic retinopathy, the cells, that nerves are little bit swallowed, and here it is the worst case, it is affected. So I can train a machine with this set of images. When a new images is captured as given as input, it will say that whether this eye is a normal eye or it's an affected eye or a severely affected diabetic eye. So even for the corona, the chest X-ray images, for a normal chest X-ray, how it looks like. If a person is affected with corona, how the chest X-ray images of the person looks like. So I can train a machine like this. So exactly when any X-ray images is given us and fed us an input, the machine can diagnose and say that what is the problem with this image. So these are the library functions which will support the algorithm. The first algorithm I already shown you. So logistic regression you can download from this particular library. Similarly, for all this I have given that different library functions. These are the outputs which I received from all the model. Now you can see that totally 64 is my diabetic patient, 114 is the non-diabetic patient. Only here, support vector machine gives the 100% output. 114 is the total normal patient, 64 is the total diabetic patient. So 2 positive, here nothing is deducting the 64, only the maximum is 40. Out of 64, 40 people are rightly identified as diabetic by the decision tree algorithm, and support vector machine identified all the non-diabetic patients, that is the normal patients. So from these results, I can say that no algorithm is better in detecting the diabetes, but I can find out that this algorithm is good in detecting the true negative and this algorithm is good in detecting the true positive. So I am combining these two algorithms and creating an hybrid algorithm which gives a better result. See that 40 and 114. Out of 64, it is able to detect 60, and out of 114, it is able to detect 114. So the percentage of accuracy is 86.51 and precision is 100%. So this is the better algorithm compared to the other algorithms. So this is the final conclusion which we can derive from this machine learning. Now I can say that my model, hybrid machine learning model using decision tree and support vector machine can be used in the hospital to detect the diabetic and non-diabetic health records of the patient. Because I proved it. I tested the algorithm, I proved, and I found that this algorithm is 80% giving better results compared to other algorithms. Okay. Any doubts in this?
No, sir.
Yeah. So in this class, so far we've seen about the challenges of IoT, how to provide the safety and security for the patients, staffs, and the healthcare equipments. I shown the IoT product development, some examples, how to monitor the patient remotely, how to control the health equipments remotely. I have a lot of health records, how to use these health records in training my machines. For this, I think I have given the solutions through the IoT and machine learning. So there are some questions. I think I can answer the questions.
Thank you, sir. Sir,
Yeah.
shall we conclude the session, sir?
Yes. I think we have reached the time.
Right.
Any questions is there? You can.
Okay. Dear participants, do you have any question, please?
Error during training and testing. Yeah, it's a good question. One of the person has asked, what about the error during training and testing?
Yes.
The algorithm, we say that underfitting and overfitting. We should not train the data with more data, and we should not train the data with less data. We don't know which one is the optimal case, but usually we have to check it. That is the one of the testing process. I have to test the algorithm with 500 data, how it is performing. With 1000 data, if I train, how it is performing. Sometimes if I train with 1000 data, it will not perform. The performance will come down. Sometimes if only 500 data, if I train, that performance will be okay. But when you are training the algorithm with very less amount of data, only 50 data I am giving for training, then also it will not perform well. So this is a tedious question. You cannot predict that what is the volume of data I can use it for predicting the training the algorithm, but you have to test it. I have to find out which is the optimal level that you can do only by experiments. I think I answered your question.
Thank you, sir. We have another one question, sir. Which simulation platform is good for machine learning, sir?
Scikit-learn, you can use it. If it is you want to do the numerical operations, otherwise you have to update the scikit-learn that is with the TensorFlow and Keras.
Okay, thank you, sir. Another one, someone to ask you. In which algorithm is better for ML, sir?
That depends on the problem. For example, the same algorithm I tested with the breast cancer data. I found that there's no need of hybrid algorithm. Their support vector machine is giving the better result. But here support vector machine is not giving better result. The reason is here I am using only 8 parameters for training the model. There I have used 31 parameters. So when the number of parameters is more, maybe the single algorithm may better. But when the number of parameters is less, you may go for a hybrid algorithm. That's why we are evaluating. No, you have to evaluate the algorithm. You find out the best one. That is one of the research. You cannot permanently say that one algorithm is better. It depends upon the problem. So always to test all the 8 algorithms, standard algorithm, and find out which one is best for your problem.
Thank you for your valuable information, sir. So now you are standing in the end position, sir. Okay. On behalf of PSR management, all participants, my heartful thanks to our honorable resource person, Dr.R.Jaichandran, Professor, Aarupadai Veedu Institute of Technology, Chennai. Despite of his busy schedule, he found a time to share his knowledge in the field of role of sensors, IoT, and machine learning in healthcare, especially for diabetes. Also, he gave wonderful information about what are the challenges in healthcare and a program to connect a sensor to Arduino and then connecting Arduino with ThinkSpeak. Also, detection and classification of diabetes using machine learning algorithm. Once again, I thank you for your nice information and technical session, sir. Thank you, sir.
Thank you.
Thank you, sir. Thank you for valuable information. Thank you, sir.
So I thank the management of PSR and
Thank
Mr. Shankar for
Welcome.
inviting me for this workshop. Thank you, sir.
Welcome, sir. Welcome, sir. We shall leave, sir. Thank you, sir.